Hi everyone, I hope you are having great build. I'm Aditya, I'm the product manager from Azure SQL. Today I'm here to talk to you about building scalable applications without having polyglot tags. Now let's talk what exactly is polyglot tags. What do I mean by that? When I say polyglot tags, I mean having the tags that you pay for choosing multiple databases. Okay, how many of you are building applications day in, day out? I'm sure everyone, right? So let's say you build a prototype. Okay, how long do you take? Based on whatever that application is, it takes. You start at 9 a.m. Before lunch, you almost have it. You can say, Aditya, it can be fast. I'm sure it's for sure fast. So, but my point is, you can build a prototype pretty fast. But let's say you built a prototype and that prototype is super successful. How do you, and then you want to add something like semantic search with vectors, you might get a vector DB, and then you extended it to have graphs, you added graph DB, and then you need to do analytics on top of it. You see what I'm doing here? You add so many databases that are specific to them. And now, because you're adding so many databases, in all of this data, shipping all of this data, if something breaks at one point, the other things won't work. Imagine the data that flows from vectors is broken, which comes to the analytics. The analytics might not give you the right answers. So that is broken. So that's the polyglot tags I'm talking about. We are here because this one we can really avoid with Microsoft SQL. Now, if let's say you are building a fraud check, a real-time fraud check application, right? How do you typically do that with all these databases? You have a relational database for order history. You have a JSON or a document databases for a device fingerprint. When I say device fingerprint, is it coming from an application? Is it coming from a browser, etc.? You might use a document database for that. For detecting multiple graph relations between multiple people, you might use graph. If you want to find similar transactions, like what would this database look like? What is this transaction looking like? Buying something from Walmart, what does that look like? Is there a similar transaction to that? There is that too, and then finally you would want all of this coming to a statistical baseline, which essentially means analytics. You have 5 different databases, 5 different sync jobs, 5 different auth systems, and because of all of this, you have so much latency because your application needs to wait to read from all of this. The costs are also the same. That's what I'm trying to say. Because you are trying to read from all of this, you have network latency, you have different security surfaces with all these databases. You have security in relational versus DW versus your graph, all of that. You have separate auth systems everywhere. You need to pay tax for that. You will have different database backups for all of this. Imagine that. There is no one single backup statement that would be doing this. Finally, more than anything, there's cognitive load, right? So which means I need to, as a developer, I need to learn 5 different tools, 5 different query languages, etc. Now, as a user, it's okay. But as an agent, it's going to be even more tough because agents with so many choices tend to hallucinate a lot. More hallucination means more wrong data, which we really doesn't want to have. That's why we are here avoiding polyglot tags with Microsoft SQL Core Engine, and not just with engine avoiding the tags. You need scale to perform and use the best of this engine. That best of this engine comes from Azure SQL Hyperscale. We will talk how Azure SQL Hyperscale helps with that. So Act 1, how to avoid the tags with all the different capabilities that we built into Microsoft SQL Core Engine. Act 2 is to how do you scale that Microsoft SQL core engine, which is the base of building the Azure SQL Hyperscale. Okay, let's go into part 1. Okay, so let's talk about the first act, which is the core engine and how we are avoiding the polyglot tax with Microsoft SQL. Okay, so let's say you have the as I mentioned in the fraud detection app setting, where you would need, if you are logging from app or if you are logging from a web browser, you need a JSON kind of a document. And how would SQL really do that? So recently SQL essentially introduced JSON native type and JSON indexes on and it is previously when we started, we kind of did inverture of max, but it's no more inverture of max. It's purely JSON type, native JSON type ANSI, and it is a pre-parsed binary, which means the way we store the JSON in our engine is a pre-parsed binary, which essentially makes JSON save 30 to 50% less. And there is this famous GIN index, which in another relational databases, where you index, when you index, the entire JSON document gets indexed. The cool thing that we did with JSON in Microsoft SQL is you can index the particular path of that JSON. So that essentially makes you feel that, okay, if I want to search only on the device, then whatever the date or anything, I can index only on the path of device in the JSON and attributes, and you can your JSON index will essentially pick that. Now, with JSON, one of the favorite features of using JSON, even for the people in document databases, is the schema flexibility. You can have a JSON document of, like, let's say 4 attributes, one of them, and another JSON document of 5 attributes. In a relational world, you might need to add one more column and all of that. That is not there with JSON. And hey, SQL supports it. Microsoft SQL supports it. And now all the JSON updates that you do and what all you do follow the same transaction boundary and no more or nothing more than that. So which means you can roll back, roll forward, all the asset properties are done. So we kind of see the Microsoft SQL. We did internally. We did the YCSW tests, and we see that we are no less than any document database when it comes to JSON performance and JSON index performance. That's why once you do this, I almost kind of say you need not really think about having a separate document database. We can essentially say goodbye and we just bank on Microsoft SQL. Now, since forever, as I said, we have invested in Graph, and you have Graph in Microsoft SQL. You can do match, and you can say the syntax is natively supported, and you can have the query optimizer understand this match and give you a perfect plan that is required for this match. And that way Graph is inbuilt in Microsoft SQL itself. So you have JSON, you have Graph, and there are graphs also very interesting scenarios when it comes to application like anti-fraud detection, fraud detection, and all of that. So you really need, wherever you need a specialist graph kind of scenarios, Microsoft SQL does support all the basic graph functionalities such that you can use Microsoft SQL for that. Now, recently, we started supporting vectors, and when we started again, we used to support vectors on top of var binary, and then we immediately switched, and vector is a native type. Now, we initially released vector type, but we haven't released the index on it. Later we released vector indexes using the DiskKNN, which is a great Microsoft research which came out from this Microsoft research, and which is essentially pretty fast than HNSW. And now imagine vector databases are kind of tricky, right? If you have a specialized vector database and if you don't have the operational data's context to it, what happens is you would end up searching a lot number of rows, a lot number of vectors, and that is costly in general. Let's say you want to search about person Bob, okay? And that person Bob is in one of the relational data. You find that person and you will select transactions similar to that, which essentially gives you more context, and hence it will help you reduce the tax on it, and it will pretty fast. Hence, essentially, it's a pre-filter. And we also kind of introduced very recently updatable Discanon indexes. So this essentially makes people who are vector databases kind of there is no need of a separate vector database. Now, clustered column store. This is one of the very famous features that SQL have. And we are continuously investing in this column store today, where so in SQL traditionally used to be its row store. You can convert them to column store, and which is more OLAP friendly, and all the data that you have for the analytics, you can transfer them as a column store, which essentially again gives a very huge amount of compression for you to on top of the row store, and you can expose that for your analytics endpoint. So that essentially gives you HTAP. One, you have the primary transactions, you have analytics, you have JSON, but just having transactions, analytics, and the real-time transactions, it makes Microsoft SQL one of the best analytical stores out there. So now combine all this story, right? Let's look at all of this. You have JSON. You got the order history of a person using relational. That's what I'm kind of doing with this. And then you kind of got the device footprint from JSON, saying by just using JSON value, and then you said, okay, for this, can you give me for the match of this for a risk score greater than 0.8, and then find the similar transactions of that in the vector table and give a 90-day baseline on top of it. And I can write all of it in a single stored procedure and execute that, and it will have one transaction boundary, which means, let's say when you're writing something on JSON, if it fails, everything fails. This is very, very important for agents, because agents, though one of the fact that we learned recently is agent needs a lot of data to read. But agent also loves idempotency, which means they come, they write. If they write, they might rewrite because of so many things, which means they need a proper rollback. ACID semantics are so important in agentic world than a normal world, because in a normal world, a developer would be sitting and making sure that, oh, this transaction has this transaction boundary, and hence when it comes to agents, they just come in, put the transaction and go out. That we should really make sure that ACID is the only way where you can know the data that is coming in is completely coming in and get committed. So it becomes even more important in the agentic world. Now, that's the part with core engine, right, where you avoided polyglot tags. Now take this core engine, take it up, and you plug that into something which scales. That is Hyperscale. That is the Hyperscale, and I call this database as peace of mind database. The reason why I call this database as a peace of mind database is when you start, there is a famous customer. He told me this story, right? He mentioned, hey Aditya, after we switch to Hyperscale, I can really sleep peacefully in the night. that made me come up with this peace of mind database with some other colleagues. The reason why I said what is that whatever that customer told me is so important is the customer need not wake up for a file group full or a file full or a log full or anything, because Hyperscale just grows as your application grows. And it has its own dedicated log service, it has its own page servers, and Azure storage. So why I typically show a architecture diagram. Here I'm not showing it purposefully, because all you as an audience need to understand here is Hyperscale has different components. You have log service, dedicated log service for your writes. Your reads are coming from page servers, which are essentially which have SSDs of its own, and it is asynchronous. The log service will do continuous redo into page servers. This page service will continuously write back into Azure storage for the durable as a durable tier. Now, if you do that, because you're writing into Azure storage, what happens is we can use the Azure storage's tech of taking snapshots. Now, eventually it became a good news for all the users, because compute on the top is not involved in taking the backups, which means there is no pages that were read to take a backup. In traditional SQL, if you are doing backup database name, you are essentially reading that backup, reading all the data into the compute and writing it back into the .back. That is not needed anymore with Hyperscale snapshot backups. Now, how in general with agents and all of this world, people use Hyperscale, right? So the way they use is they use primary for the OLTP rights. One of the major things that Hyperscale has a advantage is having named replicas. What this named replicas is, think of it like you have its own connection string for a readable copy. Now, why is that important? That is important because that readable copy essentially has its own buffer pool, which means its own memory, its own L2 cache, we call it as RBPEX, which is residual buffer pool extension, which means it has its own working set. And that working set is extremely different to any other named replica that you give. So you can differentiate working sets in Hyperscale with different named replicas, with an underlying all the same data of 128 TB. And you can have your writes not affected by reads. So we see customers doing writes on the primary, their continuous writes. We see customers doing agents pointed to the one of the named replicas, and they do vector distances, similar transactions, all of that, and find the cosine similarity and give back what exactly it is. So that from one named replica, one other I have seen customers using nightly jobs, and they use serverless specifically for those named replicas, where they go in the morning, the serverless comes to 2 vcores, and in the night when they use, they expand it to 128 vcores. They run their job, run the analytics, and they sleep off. So they use separate named replica for that. By the way, your primary can always be provisioned, and your secondary, your named replicas, can be serverless. So we also care about your business continuity, hence we do have GODR and high availability in the built-in into Hyperscale. Now let's look at the other side of it. Hyperscale comes, because Hyperscale also is a Microsoft SQL core engine. The engine itself has the best security out there. Do you know something that Microsoft SQL supports Ledger too? That's what we support even in Hyperscale, because Microsoft SQL supports it. We have dynamic data masking. You can have always encrypted, exec-only stored procedures, tenant-based execution, all of that using Microsoft SQL core engine and also in Hyperscale. Now, what is AI or agent or any talk without having an MCP server, right? So SQL has its own MCP server. We did that with the data API builder. You have so many tools that you can use with this MCP server. You have a DAB. Create a DAB, you created a data API builder using data API builder, you created that, and you get your data API REST endpoint. Using that REST endpoint, you can point that to an MCP, and that MCP can come from Hyperscale, and then that's it. So you can talk to your data which is in Hyperscale. Imagine this, right? You have 128 TB data, you have agents, you have writes, and you have MCP. You can talk to all of this with MCP with the natural language, saying update so-and-so person's name, last name to this, or change the salary of so-and-so person to this. All of it using MCP. That's what we have with SQL MCP server. Yeah, so what is, we understand that core engine, now come back to core engine is now doesn't have polyglot tags, and Hyperscale is giving scale. Whatever it is, the economics are very important, right? So in the economics, because you are avoiding polyglot tags, essentially you are eliminating all the sidecars, which means separate vector DB, separate graph DB, all of them are not there, and hence you eliminate that tags. You only pay for what you use with serverless, and it can go from 2 vCores to 80 vCores, but only when you need. If not, you will come back to the 2 vCores and pay the less bill for that. You pay only for storage from 10 GB to 128 TB. We won't over provision. Like, you need not over provision upfront, and you don't need to pay bill. Whenever your data grows, we grow with that, which means even the people cost is less, because you really need not think of having 5 different personas doing 5 different things and 5 different expertise. You can have one SQL expertise, and that's pretty much it. So Hyperscale also, imagine all of this we are giving you with a 68% better performance than our compete. So that's a steal, right? So that's why we say that Microsoft SQL combined with Azure SQL Hyperscale has the best economics. By the way, one point I really want to touch upon is Azure SQL Hyperscale is the database with licensing free model. Now, so ultimately, what is there? What is here, right? So, 2 acts, 5 ideas. I will leave you with. Polyglot tax is a choice, not an inevitability, which means it's not really needed to go to polyglot tax choice. But I also want to ground upon a truth that one size doesn't fit all, right? So there are cases where, in the extreme cases, you might need a DQP, and you really need a data warehouse. In the extreme cases of graph, you might need a separate graph databases. But all the basic scenarios, all the scenarios where, for the most of the scenarios, unless it is exceptional, Microsoft SQL covers you with an exceptional relational workload. So that's what we are saying. And Hyperscale architecture is one of the best architectures, purpose-built for cloud. And agents, as I mentioned in the talk, really need all these guarantees more than ever. So Microsoft SQL and Azure SQL Hyperscale as a story is so shining right now than ever. So all I say is avoid the tax, ship at scale, and sleep at night. Thank you.